Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various uses of chart diagram. So there are different types of charts available, and their uses should be we're going to discuss now. So the very first thing is that where we are going to create a charts. And so the main purpose is that we have to present the data in a visual method, and we can also prevent distorting data, and we can also present many members in single unit, and we can also make a large data set easy to understand, and also encourage eye to compare different pieces of the data, and it should also reveal the data at different levels of detail from border view to the structure. So why you are going to create charts? So the presenting the data in a visual method, and then how to be present, prevent the distorting the data. So sometimes the data is not up to be clear. So how can you able to do that? And then you can also present many numbers in a single unit, and you can also represent a large data set easy to understand, and then encourage this comparison of different pieces of the data, and also can able to reveal the data at several levels in a broader view to the fine structure. So in that one, first thing is that bar chart. So bar chart is going to be used for comparing the items that are not dependent on each other, and also makes the comparisons between unrelated variables. The other names is that we can also perform bar chart and column graph and histogram, then horizontal bar chart and stacked bar chart. So the other names what can able to call that for the bar chart is that so column graph. So we are going to represent the things uh, in different views. So the other synonyms for the bar chart is that we can call it as bar chart as the first synonym, and second one I can also call it as column chart, and then histogram. So histogram is somewhat little bit different than the bar chart. Uh, and if I'm going to consider this bar chart, there are different types like a simple bar, composite bar, stacker bar chart. Like this we're going to have that. So the bar charts or bar graph should be the family of the chart that can able to display the quantitative information. Normally the data will be of two types, like quantitative, and second one is that qualitative. So quantitative is different than that. So for representing this quantitative data, we're going to have a graph like bar chart, where the x-axis and y-axis. So in x-axis, we're going to represent the dependent variable, and then y-axis, we're going to represent that independent dependent variable, and here it should be the independent variable. So what are the various parts of the chart diagram? So we will see now. So very first thing is that axis. So we have two types of axis. So very first thing is that x-axis and y-axis. So the reference lines to a coordinate system. So the x should be called as horizontal reference, and y is the vertical reference. So the title is going to be describe uh, the data the chart is going to be symbolized, and legend. So the explanatory list of symbols on the chart we can able to call it as legend. So the explanatory list of the symbols on the chart we can able to call it as the legend. And labels. So these are needed for linking the chart to the information that is going to be displayed. So if the chart is going to have the labels in the spreadsheet, then the label should be able to carry over the chart. So these are the various parts of the chart diagram. So the very first thing is that, so x-axis, this one, and these are the labels that are defined in x-axis, and y-axis labels will be this, and this should be the chart title and the legendary. So legendary is this. So here, I mean, the bars are constructed with two different colors. So one blue, so blue is going to be represent one category, and brown is going to be represent another category, and yellow is going to represent another category. So here, uh, we're going to like this different synonyms. So what we're going to be following in the chart diagram. So each and every chart is going to have x-axis, y-axis, and the labels what are there, and chart title, and then legend. So what are the basic rules for creating the chart here? So here we're going to use a graph paper, and a spreadsheet program or graphic program such as Excel is going to be used. So we have to be decide on the correct type of chart or graph, and also determine the largest value number to be plotted on the each axis, and make sure that the scale is large enough to use at least half of the paper in both the directions. Okay, so the basic rules for creating chart is that we have to use the graph paper here, or you can also use a spreadsheet program, or you can able to graphing the program such as Excel. So we have to be decide the correct type of chart and graph based on the application, which should be the better visualization view. So we have to be determine the largest value number to be plotted on each axis, and make sure that the scale is going to be large enough to use at least half of the paper in both directions. So the good and then poor presentation and very poor presentation. And next one is that we have to be plot the independent or control variable on x-axis. So the dependent variable is going to be plotted on y-axis. So label the axis and give the units to those labels. On all the graphs should have a title, and good title that always works is y as the function of x. So plot the independent or control variable on the x-axis, and dependent variable is going to be plotted on y-axis. Okay, so independent and control variable should be on x-axis. Dependent variable should be on y-axis. Label the axis and going to give the units to those labels. So all the graphs should have a title, and good title that always works is y as the function of x. So here is the normal graph. So if I'm going to you follow the rules, so I have to mention what should be on dependent variable and x-axis, independent variable and dependent variable on y-axis. So what are other rules we are going to be follow here? So the most of the graphs should start at origin x is equal to 0 and y equal to 0. And so these are the exceptions like wrapping temperature. So if the lowest temperature is 37 degrees and start at 35 degrees, so this is because of 0 is not the lowest temperature. So this is one of the rules we have to be followed. So the many of the graphs we are going to be followed at 0 as a starting value, but here in some of the applications 0 is not going to be considered. So at the time we have to be take some of the initial value, and the number that x and y axis with a regular numerical sequence or pattern starting with 0 to space out, we can able to call it as a use a ruler for the straight lines. So if two or more lines are going to be plotted on the graph, so a key or legend is necessary, and different hue or symbol should be used for each line, and the color of the background of the graph and the lines on the graph should be clearly distinguishable from each other, and the color of the lines on multiple graphs should be distinguishable from each other. So if two or more lines is going to be plotted on the graph, so a key or legend should be compulsory have to be maintained. So what is this is meant for, and what is this meant for, what this color is going to be meant for. So the color of the background of the graph and the lines on the graph should be clearly distinguishable. So the lines what we are going to be drawn, and uh, the graph color should be something should be distinguishable. So otherwise it should be a unique one. And the color of the lines of the multiple line graph should be distinguishable also. So the lines what are going to problem and the values and the graph everything should be distinguishable. So what should be the general advice for creating chart is that so keep all the time keep the charts or graphs what we are going to create that should be simple. So making the data to be talking. Okay. So inserting data captures and adding attention more than any graph or special printing should also be effective. So instead of drawing, if I'm going to make and capturing of the images or graphs would also make something effect on it. So use the meaningful titles only. Don't use unnecessary no meaningless titles. So if we are going to give the meaningful titles so that the audience think about what the data means, not the what that data is or could be. So be truthful with the access. So don't exchange the scales of perspectives to gain a falsely precise advantage. So what is the values are going that should be precise one. If I'm going to do instead of 10, if I'm going to write 20, if I'm going to instead of 30, I'm going to write it as 33. So this kind of the problems or this kind of errors is going to be eliminated. And next one is that what are the basic rules for 3D? So 3D may not be a good idea because the data may be appear as distorted and can be misinterpreted may lead to misreading. So the demonstration of problematic 3D perspective. So the chart on the left should be clearly shows the twinkle edge on the door in Florida. So when the Excel shows this data 3D format, it is impossible to clearly tell anyone or if it is a 10. So next one, bar chart. So bar charts are frequently used to compare the multiple entities to show how these entities, how these one or more entries may vary over the time. They have to be identified. So the bar charts are going to frequently compare multiple entities, and each bar or column represents the data element, and complete set of columns make up the data. So the bar graph generally have one linear on the x-axis and category on the sequential scale along the horizontal axis. And these charts are going to be useful when I'm going to compare the different number of data sets or categories against each other. So there are different types of this bar chart. We're going to have that. So very first thing is that we are able to represent uh, a data element and complete columns make up a data set. So here the bar graph generally have one linear scale on a vertical axis and a category and a sequence scale along the horizontal axis. So bar chart is a column chart on its size, and this should be usually employed when there are clear categories and there is a difference between the categories of the larger. And for the column chart, the x-axis lists the different categories and height of each category column going to show the value. So here the column chart is also called as a column chart on its size. So I can able to represent this bar chart either in horizontal way or vertical way. So depending on the idea, we can able to suggest it. Suppose if I'm going to represent sales by quarter, then it should be the better view for representing a row chart. And some of the cases, if I'm going to show according to year wise, so how many number of sales that is going on, I would like to know, then it should be the column chart should be the sufficient. So there are some different types of bar charts, what I told initially. So this very first thing is that column chart. And for this bar chart, we have uh, columns chart is one thing, bar chart, stack bar chart, and then this should be stacked bar chart and column chart, row chart, and this one should be under kind of presentation of the chart. So what is this stacked column chart? So in stacked column chart, so the length of the bars should be almost all equal, and these bars are going to be divided into different segments, where each segment is going to represent the different types of values. So that is should be the stacked bar chart, and the size should almost all equal to the 100%. When it comes to the previous diagram, so this should not be equal here. This is different and this is different. So here in stacked bar chart, we're going to show several set of related data adding up to a whole with their columns stacked on top of each other. And net result of this stacking should demonstrate some value. Stacking and grouping bars should also be source to show the relationship between the data sets and help the user to compare multiple items at various points, and should also shows the relation between the multiple items change with time, and should also look for the correlation for meaningful relationship between the data sets. Okay, so here the stack bar and grouping bar should also shows the different relationships and should also compare the multiple items with various points. So here in stack bar chart, if I'm going to compare, so the comparison will also be easily when compared to different kind of applications, and the relationship between the multiple also items will also be changed with respect to time, and also we can able to look for the correlation for the meaningful relationship between the multiple data sets. And second type of chart of what we can able to call it as a line chart. Mainly this one is going to be used for the related variables and relationships over the time, and these line chart are going to be good for showing the trends of continuous data. So if I'm going to take an example like sales that is done in India, and the sales what we done in America. Suppose in 2000, or the sales will be in 2010, 2020 like this. So in 2000, then the number of sales will be around some 100, 200, 300, and 400. It should be that. In 2010, it should be 50. In 2020, it should be 400. And 2023, how it will be 400. So then if I'm going to join all these lines, the line what I can able to get, that should be the line chart. So this should be for a particular product one. So similarly, if I'm going to show the under product, how it will be, and for the product 2, uh, in 2000 it should be this, and 2010 200, and 2023 like this. So I'm going to join all these lines, so this should be underline chart for the product 2 to 6. So like this, we are going to be shows the relationship with respect to time also. So the line chart mainly good for showing the trends of the continuous data, and the area of the chart in a line chart with the area between them should be also be shaded as well, like this. So one thing under line chart should be like this, and area chart, the area that is going to be shaded under this line should also be considered as an area chart. And next one is that pie chart. So pie chart is going to be shows the parts of whole or percentages if I want to show. And this pie graph is going to be compare the components of the set to each other. And pie graphs are the member or entire family of the proportional groups. So if I want to represent the data in the form of percentages, or if I want to represent the data in the form of parts, different parts, then I can go for pie chart. So how this pie chart, suppose if I'm going to have, so product 1 sales is 20% and product 2 sales is 50% and product 3 sales is 25% and product 5 sales is 25%. If I want to show in the form percentages, so I have to make a circle and make an how much a percentage for this, so 20% and 30% and 25 25, let it be. So I can able to show it, or I can able to show it in the form of different colors as well. Normally these pie graphs are the members of entire family of proportional graphs. And next one is that the angle of the area of each slice is the same percentage to the circle as the data is going to represent. And pie graph data may be contiguous or simultaneous in time, and it may link with more by meaning than the physical proximity, or we can able to call it as a sequence. So the angle between the each area of the slice can able to call it as a segment. So each slice will also be called as a segment or wedge, what we're able to call. And so this pie graph should be maybe the contiguous or simultaneous in time. And next one is scatter plot. Here in scatter plot graph, so it is going to be used to get a visual representation of the relationship or correlationship between the two variables using XY graph method of plotting. Okay, so the scatter plot is to get the visual representation of the relationship or the correlationship between the variables. So usually the lines connecting the data points are not going to be connected. So a scatter plot is something different. So for the product one, so let it be. So I can able to print the form of blue colors, and for orange color it should be product two, and for green color it should be product three. So like this, I can able to show it how it will be in scatter plot. So normally this is representation shows the relationship or correlationship between the two variables on x and y graphing method. So usually the lines connecting the data are not going to be connected. And histograms are the bar charts that is going to display the frequency and relative frequency in the form of contiguous bar. And histograms can be used to see the shape of the distribution, also determine whether the data is distributed symmetrically or not. The histograms can be used, we can able to see the shape of the distribution, how it will be, and how we can able to determine symmetrically, and mainly it is going to use for show the relationships or frequencies. So the only difference between that bar chart and pie chart is that, so we're not going to maintain any distance between the bars. At the same time, we can able to show that presents the data for a not for in a particular variable. It is going to be shows the in between the interval values. So that is the difference between the histogram and then pie chart. So bar histograms are nothing but uh, are bar charts or sorting boxes. So there is only one variable and the data is going to be sorted by this variable by placing them into boxes here. Okay, so histograms are the sorting boxes, and the number of pieces of the data in each box is counted, and the height of the rectangle is going to be drawn on the top of each box that should be proportional to the number of pieces in the box. And next one is that the bar chart is going to have several measurements of different items that is going to be compared. And the main question is that uh, how many measurements are there in each class of measurements. So the main question a paragraph answer is that, so what is the measurement for each item and how are going to be assessed that. So histogram should be what we're able to call as sorting boxes, and the number of pieces in this one, in each box will have to be counted now. And the bar graph should also have different types of measurements of different items here, but we are going to show the data in between the intervals here in histogram. In bar chart, we are not going to present that. So based on that, we are going to have some of the measurements we have to be considered. So how many measurements are there in each of the classes of measurement, and what should be the measurement of each item, then what are the examples I'm going to see. So situation, and then based on the situation we have to be decide whether I have to construct bar graph or I have to construct the histogram. So for the first thing is that, so we want to compare two total income of five different people. This is the situation comes. So we're going to compare the total income of two different income of five different people. So at that time I have to construct what is the solution for the, either I have to construct bar graph or I can able to construct histogram. The solution is that bar graph. So how to construct what should be the five different people, let it be A, B, C, D, E. So for the income is 10,000, 5,000, 20,000, let it be 7,000, and for this is 5,000. So the five different people, I'm going to show what are the income of those five different people. But in histogram, this should not be possible. So that is one of the example. So next situation is that we have measured the revenues of several people. We're going to compare the number of people in between 0 to 10, and from in between 10,000 to 20,000, and in between from 20,000 to 30,000. So the question is that how many people are there in each of the each revenues. Suppose if I'm going to have a table like in between 0 to 10,000, so the number of people are 30. In between 10,000 to 20,000, number of people are 20. From 20,000 to 30,000, the number of people will be 35. So if I'm going to have a table like this, then I have to go for construction of histogram. So for this, I'm going to take 0, 10,000, 20,000, and 30,000. In between 0 to 10,000, I'm going to construct 30, and 20 to 30, it should be 20, and 20 to 30, I should be having this. So like this, I can able to construct the histogram. And next situation, what we're going to have to compare the height of 10 basketball players. So the key question is what should be the height of each player. So just now what I said is that, so I have to construct it three several different players, and height I have to construct 5, and the range is 6 inch, 4 inch, 3 inch. So I have to construct the bar. And the situation is that, so we have measured several players, and we want to compare the number of players in between 5 to 5.5, and 5.5 to 6, and then 6 to 6.5, and so on. And then how to construct the histogram. So in between, right? So 5, 0, 5, and 5.5, 6. So in between, how many number of people started? In between 5 and 5.5, let it be 10. And 5.5 to 6, 30. And 6 to 6.5, 50. So like this, I can able to decide the situation where I have to go for bar graph or histogram. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.